Hello and welcome to my presentation From Overhead to Guardrails, a pragmatic framework for AI security at scale. My name is Klaus. I work as a security architect with AXA in Switzerland. My main topics I work on the last years are cloud security and AI security. Plus, I do reviews for many of our most critical and biggest projects and programs to understand whether new technologies impact our security posture. Then there are three more topics I have to take care about from time to time. That's encryption, workplace security, and data loss prevention. I wrote two books, Managing AI in the Enterprise. That came out by Springer and A-Press like 2 or 3 years ago. And a new one, the definitive guide to cloud security architecture, which is relatively new. It's with LeanPub and it's work in progress. So I'm really excited today to have the chance to combine security and AI in one presentation. And we see a fundamental shift in security. I know very well an article I wrote about AI and security 2 or 3 years ago. The risks were completely different. At this time, AI was mainly about machine learning. And in machine learning, you had 3 security risks. Number 1, cloud compute is needed. You need massive amounts of virtual machines, of computers to train neural networks. And this compute power is certainly interesting for attackers who might try to get into your systems and steal the compute to run crypto miners. So that's risk number 1, someone hijacking your VMs and letting you pay for crypto mining. Risk number 2, 2 years ago, was the training data. I work for insurance, so the historic data is very important to make good pricings and fair pricings for the customers. You don't want to overcharge, but you also want to get your risk covered. So historic data is highly interesting. Also, I assume some of you might be living and working in California or Texas. Think about someone training a self-driving car. You're going to need tons of material and video recording of cars driving around roads under all weather conditions. This is valuable for attackers who might start their own startup and steal your data. So risk 2, training data. And risk 3 at this time was consultants trying to convince you to spend money on irrelevant problems. Do you remember the discussion about changing pictures to get a different result and getting on classifications? Well, I never heard about any security vulnerability or risk that built on top of that. But you must not forget, this was the situation 2 years ago with machine learning. Today, AI focuses a lot on large language models. And here we see completely different risks. For example, you might have heard the case some weeks ago that AI or vibe coding tool deleted a production database. The engineer said, don't change anything. The AI deleted the database. And when the engineer asked, is there a backup? The answer was no, so there was one. This is a high security risk. Number 2, you might have heard about the zero-touch vulnerability with Microsoft's Copilot. What happened? Someone could send a malicious email to you. You do not open the email, but you send a kind of request to Copilot that results in this malicious email being processed. And then the malicious email is going to get some sensitive data from you and exfiltrate it to the outside world. This is a very, very serious risk. Number 3, manipulated peer reviews in academia. What happened? I mean, you submit an article for review at a conference or in a journal, and then colleagues of you are supposed to read your submission and make a statement whether it's valuable, whether it's good, or whether it's not so interesting. What were people are doing? Well, they were just inserting hidden text to trick LLMs, because some of the reviewers were, even if they're not supposed to do, use LLMs to save time and write the reviews. And now someone who submitted papers were trying to trick them and make the LLM to give good grades just by using prompt injection. And the last one, the last attack vector was really the one that caught my attention. I thought, well, if you're in insurance, If you're just processing documents, you have to be very careful because someone might send you a document with a prompt injection command, and in the end, you're transferring 1 million to a bank account on the Bahamas. And that's what nobody wants. So today, the risks are much higher. With LLMs, much more is at stake than in the past. The good thing is, OWASP and many other groups really looked at the risks associated with agentic AI and large language models. Today, there are many frameworks to assess the risks and to define mitigating actions. So if you're a manufacturer of a helicopter, you have all the tools and frameworks at hand that help you to design a safe AI that controls your helicopter. That's the model. One super AI that controls a large system. Everything is in place, what you need. My issue is, I'm not working for a helicopter company. I work for an insurance. That's about people having car repairs and needing their money back. It's about health insurance. It's about travel insurance. You have many, many systems where you have to process customer documents and to decide, oh, is this the case that is covered? You have to interact with customers, explain your services. So you have not just a single AI, you have dozens of AIs. This is my reality. You have RAGs and LLM, they're going to spread over the next month everywhere. You still have the machine learning for pricing information, for risk prediction, they're perfect. We're also going to have vibe coding. So we have AI, it's not going to be one AI system like controlling a helicopter, but AI everywhere in your software stack and on all applications. That might be the vision. And now there are two issues. And I symbolized the first one with the monitor and the newspaper on top of the screen. What is it about? Most of us are in the good situation that they only have theoretical knowledge about AI attacks because we read about them, but most of us have never experienced one. This is different to classic malware attacks. Everyone knows them from the past, they know how to handle them, but AI is new, AI is frightening. On the other side, all the documents and books are very, very helpful. They guide you. But now again, we're not a helicopter company with one AI. We have dozens of AIs. So all the good documents that you are able to read, you cannot distribute them to the engineers. Let me compare this with the introduction of cloud and the security aspects there. Some people said when the cloud appeared, now you have to train engineers that they don't misconfigure S3 buckets. Well, some training makes sense, but in the end, if you have hundreds of thousands of engineers, you can't pull them out of their normal work, train them for a week, don't allow them to do anything, do the same training for all new people, because in the end, we don't hire them to become cloud experts or AI experts, we hire them to write software that helps customers of an insurance. And so having hundreds of documents with good and valuable input is not really helping me when I have to care about hundreds of engineers running dozens of AIs. What I need is clear implementation paths. I have to have scenarios, and then I don't need a path, I need a road or even a German Autobahn. I tell the engineers, well, you have an LLM problem, that's the road for a RAG. Go there, nowhere else. You have machine learning, that's the road to take. Vibe coding, that's the road. The second aspect is, well, focus on what matters. Might be completely different. Some of you might have to do a lot with IoT. I'm more experienced with business applications in the financial industries, banks and insurances. And if I tell an engineer in a bank or an insurance, well, you have to take care about the data, well, they say me, well, thank you for telling me that. I know this for decades because this is in the DNA of an engineer here. Not an issue for us, might be an issue for others, but what's an issue for us is the indeterministic behavior and the unclarity that LLMs brings, plus the risk of prompt injection. And this is new, and this is really serious because it can impact the result of business processes and workflows. It can impact what contracts we sign, and it opens the door for fraud. But when we talk about prompt injection, I don't have one prompt injection problem. Remember my picture. I have dozens of prompt injection problems, and I have to cover them all. And this explains what our requirements are. Well, that's motivation for them. We need a basic safety net against prompt injection, centralized, very easy to use. If you order a server or VM, malware protection is included these days. And the same must be very clear. If there's an LLM and a RAG, prompt injection must be included. This must be the goal. Second one, there are certainly use case specific hardening and testing requirements. It's different whether you write a chatbot with an LLM for underwriting or for processing health claims or for claims from customers in the car insurance industry. So the fraud cases and the risks differ. So you have also use case specific necessities that you have to cover. And finally, a solution that just looks at chat text is not enough. We need protection against documents with prompt injections, because we are receiving them today. We might process them in years to come, and we don't want a document with a prompt injection to result in a money transfer in 6 months. We don't want that. So on the technical side, we have to work with what's available today. And at the moment, the best solution as a technical solution is using a cloud provider service against prompt injection. Might not be perfect, but at least a very good start. And where we want to go to is going to a strategic solution, having a dedicated AI security module or solution that covers these risks. And if any of you has experience from the corporate world how these tools work, what you are using, I'm very happy if you can contact me on LinkedIn to learn from you. Now, something for people who are not so much for so long in IT security and might not be aware of some political aspects here. Other teams are very good to moving bad and critical decisions to security teams. So if you're in cybersecurity, it's best to know what is your problem and what is the problem of someone else. So you want to take care about the CIA triangle: confidentiality, integrity, availability. You want to take care about workload and access to data. And there are other important problems that are super important for your organization, but they might not be information security problems, like unfriendly chatbots. We don't want a chatbot to insult customers. You want to provide chatbots to provide correct information and make the right actions. This is important. Again, that's more of a business problem. Data protection law, very important, but that's something lawyers have to take off. So what I learned in information security, it's really important with the new topics to clearly separate what's an information security problem and what is an important company problem, but not an information security one. Because in the end, you want to reach scalability, and you won't reach scalability for AI security if you don't have clarity and simplicity. And now I'm coming more to the framework aspect of my presentation. And even if I say the word here simplicity, you're going to see the most complex slide of this presentation now, but it's a very simple one. Because in the top row, I just enumerate the different use cases or usage scenarios for AI that we have. You might have different ones, especially if you're doing more IoT, it might look different. But for us, risk number one relates to the machine learning risks. You want to secure your data pipelines, training pipelines, your models, and you want to protect your compute environments against attackers, for example, who are interested in running crypto miners. Scenario two, RAG LLM chatbots. Here we have an application security challenge. The chatbot, the agent, the LLM, they might all run on different platforms. So you have to glue them together without causing any risks. The prompt injection challenge is here very, very vivid. And also the problem of sensitive data disclosure risks. If I chat with a chatbot, I hopefully don't get the account balance from my neighbors. That's what we don't want. Scenario 3, vibe coding. Here, it is important to distinguish what the potential of vibe coding and the reality. Even if everything is going to be perfect in 2, 3, or 5 years, we have to understand the risks vibe coding introduces now. And this is most probably your code is going to have many vulnerabilities. There's the potential risk of misbehaving vibe coding tools that decide to delete your database. That's scenario 3. And you see scenario 1, 2, and 3, they are in green because we really understood them very well. And the red one, the blending and the multi-agent thing, that's something we are working on. It's, again, the prompt injection challenge. There might still be issues with the misbehaving systems. And there's certainly the system stability challenge because nobody knows what's happening if there are 40 or 50 agents behaving relatively independently. So top row, research scenarios. Lower row, these are sourcing topics. In AI, we tend to have many external tools, or at least rely on external libraries and images. So we have to look at them as a dedicated kind of risk category. I'm starting to the right, supply chain. This is if you take libraries, models, Docker images from external sources. Can you trust the LLM that no one plays around with the rules it's following? And can you rely on the models? And especially if you're, for example, getting Docker images, are you very sure that there's no malware included? So, supply chain, that's the biggest risk for code fragments, components you get from external and install yourself in your parameter. The integration risks, exfiltration, and fourth party, these are risks that relate to SaaS solutions. So if you integrate your SaaS solution with your internal application landscape, well, I think you want to be sure that the user management works. Assume you have a vibe coding tool and you don't integrate the IDP or the identity management. What's happening then? Well, an engineer leaves the organization, he's still able to change your code. API protection, while the vibe coding tool accesses your cloud via Terraform, do you have an API key or do you have an IP protection on top of that, IP filtering? It's up to you. The exfiltration and sharing features, they are great and startups like them so that you can show around all your colleagues how great work you've done with this new tool prototyping. Well, if you can share access to someone else outside the organization for your code or your machine learning results, or even your training data, that's something you probably don't want to have as a feature in your SaaS solution. And finally, the fourth party service integration. If you have an LLM and you use MCP to connect to external services, this might have some unwanted implications. For example, you open the access to booking.com. Now everyone can book free holidays. Is this what you want? Or you're combining an LLM with an external database. Now, can you prompt a lot of sensitive information into this external database that doesn't belong to you? Do you want that? Well, you see, sourcing is an especially challenging topic in the context of AI. And you can't address all these risks if you just see it as a technology problem. You also have to make sure that your organizational processes help you reduce the risk. I want to be more practical now, that we really get to the point of the guardrails and the framework. I want to show you how this one helps you understand and classify risks. Assume a chatbot with a RAG, and you build this on top of a cloud-native service, an LLM, for example, provided by Azure, by GCP. And in this case, well, from all these risks, only one is relevant. There's no sourcing involved. It's just one scenario, the RAG, LLM chatbot, address these risks, and you're safe. Cursor AI as a vibe coding tool. Here, many more of these risks are capable. You have the vibe coding risk, and you have the whole complete flavor of external integration and SaaS integration. And you have to check which of these risks really apply for this specific SaaS service. And that's where we get to the framework and to the guardrails. You have to define your risk appetite, and then you can define what you want to do. So, well, you see here some marks saying it's okay, it's not okay. We shouldn't just think about yes or no, or good or not good. Often it depends on the scenario. Certain risks might be okay if you're prototyping. They might be okay if you're using it in production, but they might not be acceptable if you use it in production with sensitive PII or so. So you have to decide for each of these risks, of the usage scenarios and of the sourcing topics, whether you're willing to accept these risks. That's a management decision. Yes or no. And if you say you don't want to accept the risks, there are different options how to approach that. Approach one is you don't allow the service. If there's a sharing feature in a vibe coding tool that allows others to access and work with your code outside of your organization, that can be a decision where you say, well, I don't care how good the tool is, we're not using it. There are also alternatives, like if you say, okay, there are vulnerabilities in vibe coding, so I don't want to take this risk, but I know mitigation measures. So I say you have to use code checkers, security testing tools to mitigate this risk. Or you say, okay, there's a fourth-party service integration risk. Well, I want to know to which other external services my LLM connects to. So I set up a governance and a monitoring on top of that. If I'm afraid that someone is stealing my, let me pay for his crypto mining, well, a CSPM that protects your cloud and your machine learning environment might be the right solution. So just look at this picture. This picture is your tool if you want to have a really some kind of rules and kind of framework that really fits your organization. You have to check the usage scenarios. You have to understand the sourcing topics. You have to define your risk appetite. And then you can work with your colleagues on defining mitigating measures, or whether you're saying, okay, I'm not willing to take risk. So, and with all the things that I said today, there are three main points that you should really remember. You have to design for scalability. Scalability matters. And in order to get scalable, you need to centralize as many of the AI security topics that you can. And then finally, you need clear scenarios, as I've shown you on the slides before, clear scenarios for which you have simple and easy to follow guidelines what engineers have to do. Combine these three topics together and you're going to be a champion in AI security that many colleagues are going to ask if they have to make difficult decisions. That's my presentation. Thanks a lot for your interest.